Okay, good afternoon, everyone. Thanks for joining us today. My name is Daniele. I'm a solutions architect with AWS. I'm based in London. I'm joined on stage today by Dan, who's a senior manager with the AWS Developers Tools. This is a 300-level session, so we assume that you are familiar with some concept around containers, ECS, and Docker. What we want to do in this session is provide you with some highlights and why you may want to use containers and how they can help you to deliver better quality software. We want to dive deep into some tools and services that you can use to implement the concept that we'll be talking about today. And finally, we will show you how to actually do that. We'll have a few demos along the way as well. I'm sure you already all familiar with containers and the benefits of using them, but just to be on the same page, let's just go through them very quickly. Containers are similar to hardware virtualization like Amazon EC2, but instead of separating on a virtual machine, containers use process isolation on the operating system. Containers are very portable. That's probably one of the main advantages that we'll see today. When you build a container image, that image will be the same. It doesn't matter where you run it or when you run it. One of the advantages is their speed. The container, they start very fast. The operating system is already running, so they're very quick when they start. And finally, they're very resource efficient as well. You can specify exactly the resources that your containers need in terms of memory, CPU, network. And usually, that will give you a better resource utilization when compared to running the same processes on virtual machines. So how can we make use of those benefits when running our continuous delivery workflow? Continuous delivery is all about reducing the risks and delivery value by producing high-quality software. That means that we want our software to be in a state that we can deploy it at any time throughout its life cycle. It means that whenever we make some changes to our code, we want to get some feedback that is fast and automated. And also, that means that we can pick any version of our software and deploy it to any environment that we may have. Because containers provide a very predictable and consistent environment, they can help reducing the risks. And also, thanks to their lightweight, they will help with speed and agility. As I mentioned earlier, we have a couple of demos along the way. We're going to be using a very simple Ruby on Rails application. It's an Instagram clone, so you should all be familiar with what it does. That application is fronted by an Nginx proxy, and these two components will be running in Docker containers. We'll also be using an PostgreSQL database, and we'll be running that on Amazon RDS. We ultimately will deploying our containers on Amazon EC2 Container Service, which is a very scalable container management service. It doesn't matter whether you want to run few containers, thousands of containers. Amazon ECS will provide you the performance, and it will scale seamlessly. We also provide with Amazon ECS a few options for placing your containers, for scheduling your containers on the cluster. As we've heard this morning from Werner, there was an improvement in one of the containers that we provide. But we also expose the cluster state through the API, through a set of APIs, so that you can implement your own scheduler if you want to. And Amazon ECS is also highly integrated with the existing AWS services, such as Elastic Load Balancing or CloudWatch, so that you can use the same features and tools that you're already used to. Just to remind you some of the key concepts of Amazon ECS, we have a cluster, which is a pool of resources that your containers can use. Those resources come from container instances, which are basically EC2 instances where you can run your containers. As I said, they are your EC2 instances, so you own them, you control them, you can log into them, and you can see how things run under the hood. And then we have the concept of task definition, which is basically where you define what containers you want to run, what images they use, how many resources, and so on. And then you can schedule those task definition onto a container instance, and that would run a task, basically. For our application, for our sample application, the typical workflow will look something like this. We have our source that we write on our development machine, on our laptop, for example. We make some changes, push them to a code repository. Typically, that would trigger a build on our build environment that would create the new artifacts for our new version of our code. Once those artifacts are ready, then we can test them, make sure that they don't break any existing functionality, for example, and then we are finally ready for deployment. And ideally, we would want to have an orchestration layer as well that can take care of all these processes. We'll now dive deep into each of these sections, and we see how containers can help at each stage. As we said, the first step is actually your application code. This is where you write the code, your machine, for example, your IDE. You write some code, make some changes, test it locally. Once you're happy with the changes, you can finally push that to a code repository. And that can be a distributed code repository so that multiple developers can contribute to the same project. So one of the tools that we want to highlight for this particular stage is AWS CodeCommit, which is a managed private Git repository. So you don't have to worry about installing your source control system. You don't have to worry about backing that up, scaling it. We take care of that for you. CodeCommit also encrypts your data in transit and at rest, so we can provide a secure solution for your code. And thanks to the integration with AWS Identity and Access Management, you can provide user-level permission on each of your repository. And finally, we run CodeCommit on a scalable and highly available solution infrastructure, so your repositories are available and they can scale seamlessly. There are also alternatives, of course, to CodeCommit. Probably the most common one would be GitHub and Bitbucket. For our demos, we'll actually be using a private repository on GitHub. When we talk about containers, we refer more and more often to Docker containers. Docker is now available on a variety of Linux distributions with a recent kernel. It's also available on Mac and Windows through the Docker Toolbox tool. One of the interesting things about Docker is that you can define the application environment that your application will be running in and any additional dependencies using a Dockerfile. This is the Dockerfile for our sample app. So we start from a base Ruby image. We then install some additional packages using the operating system package manager, apt in this case. We then install the application dependencies using the gem file, and finally we copy our source code on that image. We now can use this Dockerfile to create an image, to create a container image that then will be used throughout our software lifecycle, so in the build, test, and deployment stage. One of the most interesting things about Docker is actually the tools ecosystem that it comes with. One of these tools is Compose, and Compose allows us to run multi-container application in a very simple way. We can simply define each component using a Dockerfile, like what we just saw now. And then we can specify how the different components are linked together or they relate to each other in a Docker Compose YAML file. And then with a simple command, docker compose app, we can start all the components at once. Again, this is the compose YAML for our sample app. We have two components, like what we mentioned at the beginning, a proxy and the web. We build the proxy from a Dockerfile that is in the proxy directory. And then we map the port 80 on the container to port 80 on our host so that we can actually access the container. And finally, we link our proxy component to our web component. In a similar way, for the web component, we build that from a Dockerfile in the web directory. As we said, it's a Rails app, so we specify the command that we want to use to start that application. And we also expose a port, but that port will only be exposed to any container that is linked to our web component, not on the host. If you're already using Compose, you'll be glad to hear about this new tool that we announced this morning, the ECS CLI. With the ECS CLI, you can now run those complex applications that you define in your Docker Compose YAML on an ECS cluster, and you can also scale that cluster up and down as needed. The ECS CLI is available today. You can go and download it. It's also available on our GitHub repository, so please contribute to that as well. This is how it would work. We simply configure the tool by specifying our AWS credentials, the region we may want to use, and the cluster and the ECS cluster we want to use. And then we can run any compose command, for example, build, in this case, to build our images, or app to start our application. In this case, I'm using the local option so that those containers will be starting on my local machine. For our demo, we'll actually be using Docker Compose, and I'll switch now to the demo to show that. Okay, so I've already built my images, so all I need to do now is simply run my Docker Compose app. This is using my images, starting them. Oops. Okay, my application is now up and running. I can switch to the browser and point my browser to the IP address of my virtual machine where I'm running Docker, and this is my app up and running. I can then register, for example, specifying all the parameters that are needed. Yeah. Yep. Yeah. So I can just, again, try to log in with the same password. Apparently, I cannot type. Okay, so this is, as we said, it's a simple app. It's an Instagram clone, so I'm not going through the features and the functionality of this app. But let's say that we want to make some changes now to this application. So let's terminate this one and switch to my source code here. Can you read this text, or should I make it a bit bigger? It's good? OK. So let's say I want to change the title. Let's call this app Photogram at Reinvent. And also I want to change some of the background images to make them a bit more contextual to our reinvent. I've made my changes now, so all I need to do is rebuild my images and then up again with my Docker Compose. Once the app is up and running again, I can now refresh these, and I will see the new version of the app, new images, and new title. I'll pass it on now to Dan. We'll go through the build and the test phase.
All right. So we've learned how to get a Docker-based application running in a development setup using Docker Compose and also using the ECS CLI. But this whole talk is about continuous delivery. So what we'll learn now is how we take this Docker setup and automate it, starting with our build and our test, such that we can put the whole thing together in a completely automatic continuous delivery pipeline that will eventually take us from a Git push all the way to production. So let's learn how we do this. Oh, it's reversed.
Yeah.
We have a number of options for automating builds and continuous delivery pipelines, many of which are provided by AWS partners. A good example, and the one that we'll be using for this demo, is Jenkins in a combination with plugins coming from CloudBees. CloudBees also provides an enterprise continuous delivery solution, but we won't be getting into that one in this talk. Other providers include Solano Labs, again, full continuous delivery targeting Amazon ECS, Worker, CodeShip, and Shippable, all of whom can be used to target Amazon ECS-based workloads. But for the purposes of this talk, we're going to focus on a simple use of Jenkins, which is one of the more popular solutions in the market. So why Jenkins? It's simple to set up, it's extensible, it provides for flexible builds, it supports Ant and Maven out of the box. It now has support for building Docker images without writing any code, courtesy of CloudBees plugins. And you can take Jenkins jobs and run them themselves in Docker containers, which we're going to see a demo of fairly soon. All again through plugins with minimal or little code and configuration needed. So we're going to focus on the CloudBees Docker Build and Publish plugin as the main part of our build. If you recall from Daniela's portion, we ran Docker Compose build, which created and built 2 containers. What we have to do during our build is we have to get our automated build to build the same 2 containers from 2 different directories and automatically publish them to a registry. And the Docker Build and Publish plugin will do this for us, again, with no code needed. From here, we're going to switch into a brief demo where we'll walk through the real settings. So what we're looking at right now is a Jenkins tab on the settings for our build. Now, for those who are familiar with Jenkins, this is a freestyle project. You can create one of these simply by going to Jenkins and creating a new freestyle project, and that will give you all the options you need. We've given the project a basic name, Photogram Build. We will skip over a few sections that we'll get to later when we talk about configuring this in CodePipeline down the road. But for now, let's focus on the Docker Build and Publish section. So the first piece of building and publish is to pick the name of the repository where we're going to push. Right now, we have a custom repository sitting, it's a public repository, sitting in Docker Hub, and that's where we're pushing our images. Next, and very important, we associate a tag with our image. One of the features of Docker when you push to a registry is that you can place a tag name on your images. So you can have an image with a distinct name and many different tags. We pick a tag that varies based on the build number. The reason we do this is for repeatability. That way we know that if we just ran build number 37, v_37 is the tag that contains the Docker container that was precisely created from that build. This is going to be important if we ever need to roll back or produce a repeatable build, which is a very critical component of continuous delivery. In some cases, we could set server credentials. In this case, we don't need them, and registry credentials to let us push to the registry. And then we'll go into the Advanced tab. This section is important. We have to specify the directory the Dockerfile lives in. If you recall from looking at the dockercompose.yaml file earlier, we had 2 containers, each of which lived in a separate subdirectory, each of which contained a Dockerfile. And this setting specifies that we have a Dockerfile under the web subdirectory. So this configuration will let us build the web container automatically. We then repeat a similar process for the proxy container for our Nginx. Once again, we give it a repository name. It's slightly different. It has the proxy. We tag it based on the build number, set our credentials, and we go into the Advanced tab, and this time we specify that the Dockerfile lives under proxy. That way it will use a different Dockerfile and create the Nginx instead of accidentally creating our Rails app twice. We will get to, there are some more configurations needed to work the build into the full continuous delivery pipeline, which we'll get to a little bit later when we put everything together. Now we'll swing back to our slides. Escape F5. Got it. So I mentioned the registry, and we were using Docker Hub. That's what we're using for the purposes of this demo. But as announced this morning, another option is coming up soon, and that is ECS itself will host private Docker registries. The ECS hosted registries, the Amazon EC2 container registry as we call it, is a private Docker registry. It's V2. It supports full AWS authentication via IAM, and it supports low latency pulls, push, and inspection. And still, this is not the only other alternative. Docker Hub supports private registries. For a fee, you can use them through Docker Hub. And through our AWS Marketplace, Docker acts as a partner and gives you what's called the Docker Trusted Registry, which can let you spin up your own Docker registry on your own EC2 hardware if you so choose. Regardless of which method and on top of that, you can actually simply take the open source Docker registry and self-host it. The nice thing about the Docker Build and Publish plugin is it's completely agnostic to the registry you use. Pick any of these and your build process stays pretty much the same. The only thing that changes is the address of the server and the credential system that you use to talk to it. So now we're going to talk about test. And testing is important because you can't actually have continuous delivery if you're not testing anything. It's not very wise to git push your changes straight through to production without running any tests. So test automation is pretty critical. As with the build, we're going to be using Jenkins to automate it. But first, let's get into the platform we're going to use to run our tests and how we've constructed it. Because we're running a Ruby app, we're using a popular framework for Ruby testing called RSpec. Now, for those of you who are familiar with Ruby on Rails, you may know RSpec in its traditional use to write unit tests for Rails sites. Typically, RSpec runs directly against what's called the rack middleware server, letting you easily write unit tests that have a very simple script-like feature to let you test your site. The problem with these tests is that they don't hit live endpoints. They patch directly into the rack server, so they could literally only run in your development environment and only function as unit tests. But that's not what we want to do here. We want an integration test. We want to have tests to verify that the live environment that we've deployed our code to is actually functioning correctly. Fortunately, there are tools that let us run RSpec against live sites. The one I'm using is called Capybara WebKit. It uses an internal headless WebKit browser to direct the same RSpec code that you would use as a unit test against a live site. The only rub is that it relies on a fair amount of native dependencies, including a headless X server called XVFB, which have some trickery to them and can occasionally get stuck running and leave your machine in a little bit of an odd state. But when you use Docker and containers, these become much less of a problem. And we'll learn how this works. We're going to automate this test using Jenkins. And when we run the test, we're going to go a step further than what we did with the build, and we're actually going to run the tests themselves on a Docker-based slave. So we're taking it to the next level. This is going to involve another plugin from CloudBees, and this plugin is known as the CloudBees Jenkins EC2 plugin. If you're familiar with Jenkins, you'll know that it's a master-slave architecture. So you have a main machine, which is called the master, and that's actually how we ran our builds. It's just one box. It configures your jobs and runs everything. You can also configure Jenkins in a distributed mode, which is called master-slave. When you use slaves, you set up additional machines, and they can run additional jobs, even running them in parallel, get you scaling, get you speed. Under normal circumstances, you have to pre-configure your slaves and leave them resident, which can be a bit of a pain if your slaves are carrying a lot of dependencies around needed to run your test code. With Docker and with ECS and with the ECS plugin, however, you can configure slaves such that the slave is spun up as a container on your ECS cluster. It runs your test or your job and then spins the whole thing down when it's done, leaving nothing resident and leaving no configuration behind. And that's how we're going to do this. So before we get into the configuration, a little bit about the Dockerfile we're using. Daniela showed you the Dockerfile that we use to build our apps. Now we have an additional Dockerfile that's specific to the slave that we use for our tests. It's a little bit more complicated, but not too much. It starts by descending from the JNLP slave. This is simply necessary to let the container function as a Docker slave. It contains the basic Java infrastructure to communicate with Docker. We then install all the dependencies we need, which include Ruby, XVFB, Capybara, Capybara WebKit, and a whole pile of gems. It seems like a lot, but because the Dockerfile contains all of this, we now have a containable, repeatable test environment that we don't have to keep reinstantiating. And this is just the finish of the same Dockerfile. Again, we install our gems, set the user's Jenkins, and we're ready to roll. Go back, because some people are taking pictures. Now we're going to flip back to our demo. So the test configuration is, again, a Jenkins freestyle project, just like the build was. It's a separate project. I'm not bundling my integration tests with my build. That's not a best practice. We got them separate. But we're going to do one thing different right near the top. And you'll notice this box here called restrict where this project can be run. This is going to select what's called a label that connects us to a cloud that we've configured through the ECS plugin. I'll take a quick detour now and show you how we actually configure that cloud to allow us to use that box. So to show this, we go to our Jenkins, the front of our Jenkins, and I'm going to click Manage Jenkins, which takes us to a configuration, and then Configure System. Scrolling down to the very bottom, you'll see a section called Cloud. When you have the EC2 container service, the CloudBees ECS plugin installed, you're going to get this section added to your Manage Jenkins at the bottom. First, we pick a name for the cloud. We'll just call it ECS. We put in our Amazon credentials that let us talk to ECS, after which we get a nice drop-down that shows all the different ECS clusters that are available on our account. For the purposes of this talk, we picked one called Staging. We then pick a label, and this label is important because the label here, ECS slave, needs to match the label that we picked when we configured the test job. So if you remember ECS slave over here, and ECS slave over here. Those need to match. Next, we pick the Docker image. So for the purposes of this talk, we built that from that Dockerfile offline and pushed it up to the repository. You could actually configure that as a Docker build if you want. We set the file system root, which is specific to Jenkins, set memory and CPU units, and we're ready to roll. Now we have a working cloud. So back to our test config. We've selected restrict where this project can be run, which tells Jenkins, whenever you see this test job execute as a build, always fire it off on the slave, which in practice is going to mean fire up a new container, set up a task definition, run it on the ECS cluster, and then tear the whole thing down when it finishes. I'll skip over source code management again until we talk about CodePipeline and get into what we're actually executing. So the command to run our tests is actually very simple because we pre-installed all the dependencies. We just connect to the web directory where we're running all the tests. We set the name of the test server. In this case, I've set it to the URL for the beta site that we're hitting. The nice thing is that this is fully parameterized, so I could create another test job and hit a different site, and all I'd have to do is modify this line. Then we invoke the test via xvfb run, which tells our headless web server, xvfb, fire up a headless web server temporarily, run our RSpec test with the server functioning, with the display set, and then tear the whole thing down when done. Very, very convenient command. And when run within a Docker container, it's even more safe because it's completely isolated from the rest of the OS. And that's our step. That's all we have to do to execute our tests. There are some post-build actions which help us integrate with CodePipeline that we'll see later, but that's our entire configuration. And now I'm going to hand it back, and we'll talk about how to deploy and then how to put it all together.
So we have our test and build cover now. All we have left to do is actually deploy our containers. As we mentioned earlier, this is the stage where we take the artifacts and deploy them to our production environment. We will deploy on Amazon ECS, and again, as announced this morning, we have this tool that allows us now to take our Docker Compose file and run it on Amazon ECS cluster. It's a simple command. Again, it's a compose app. In this case, I'm not specifying the local option, so this would actually run the containers that I've defined in my compose file on my ECS cluster. It will also take care of converting my YAML file into a task definition and run a task with that task definition. And then I can also list the containers that are running with the ps command, for example. For this demo, we're going to be using Elastic Beanstalk, which is a simpler way to deploying containers within a pipeline like what we're doing now. Beanstalk, one of the benefits of using Beanstalk is that it can manage all the resources for you, so your databases, your Elastic load balancing, your ECS cluster as well. And it also provides some additional features for your application, monitoring, logging, for example. One other advantage of Beanstalk is that we can create different environments for the same application. We can have a beta environment, we can have a production environment, and they can all be identical. So we know that whatever we test on our beta environment will be the same as what we have on production. We have two options with Elastic Beanstalk. We can run single containers application, and that would run on Amazon EC2, or we can run multi-containers application like in our demo, and that will deploy on Amazon ECS. You would want to use Beanstalk if you just want to take advantage of the benefits of containers, but you still want the simplicity of just deploying your app and move that from development to production by simply uploading a new container image, for example. If you need more fine-grained control over the placement of containers and so on, then Amazon ECS would be a better option in that case. As we said, it would be nice to have a tool that can take our source code from the repository, build the artifacts, test it, and finally deploy it. And one tool that knows how to move through these different stages. And that tool that we're going to use for our demo is AWS CodePipeline. With Pipeline, we can automate the delivery of the software, and we can assure the quality of the software. We can model our release process using a graphical process, using a graphical interface, and then we can run all the changes that we make to our code through that process that we defined, and that would assure that all the changes will go through the same standardized process. So let's switch again to the demo and see how all these tools work together end to end. So the first thing I'm going to do is to actually push the changes that I made at the beginning to our code repository. So I'll just check what changes I made. I changed a couple of files. So I'll just add them, commit with a nice comment. Don't forget those. And then I'm ready to push. So this operation, push into my code repository, would actually now trigger the execution of the pipeline. So if I switch to my console, we will see in a second or two that this initial stage of the pipeline would turn blue and will start executing. In our pipeline, we have a few stages. We have our source, which is our GitHub repository. We have our build stage, that's where we're going to build the software. We then deploy to a beta environment, run some tests, and finally deploy in production. I'll pass it back to Dan that he's going to go over the build and test environment, and then we'll see how we do the deployment.
So as you can see, our code pipeline has picked up our changes, and the source stage is now running. While our pipeline runs, let's learn a little bit about how we've hooked everything together, starting with build. So you might recall that we skipped over some pieces of the build configuration before. Now we're going to go through them. So near the top of our build configuration, there's a section called Source Code Management. Normally, when you're writing a Jenkins project, this is where you would configure Git directly, or you could talk directly to AWS CodeCommit or to your source control. But when you're using CodePipeline, you actually select AWS CodePipeline as your source control system. You pick your region, US East 1, and no need for AWS access keys in this case if you've set up an instance role behind your Jenkins box, as we have. It just uses the default IAM configuration. Then you pick two values that need to match your pipeline configuration. One of them is called the category, in this case build, to indicate this is the build stage. And then the provider, which is Jenkins build, which matches the provider that we sent for the corresponding stage back in CodePipeline. So if we go back to our CodePipeline and look at our build info, actually you'd have to go to the edit view to do it. When we create our build step, we actually need to set the name of a provider and set the type, and those need to match between the two. Going back to our Jenkins configuration, remember there's a third step in the build that we also glossed over, which is important in how we're connecting with AWS Elastic Beanstalk. Notice that we have an execute shell script sitting right after the two Docker steps. We run this command against a build script that we have called build.sh. Let's take a look at what that actually is and what it does. This is our build script. All this really is it's removing some temp directories, it's creating an output directory called build where we're going to place an artifact, and then it's running a simple sed script to substitute a build number expression with the actual Jenkins build number in a file called dockerrun.aws.json.t, which it then generates into the build directory. So what is this file? If you're familiar with Elastic Beanstalk, you may be aware of this, but if you're not, no worries. This is a configuration file used by Elastic Beanstalk to orchestrate multiple containers. It's similar in spirit to the Docker compose.yaml, although it refers directly to the images that we're using. This is what our template file looks like. You notice that we have two container definitions. We have our proxy, and we have our web. And for both, we have images. Let's take a quick look at the image for the proxy container, and this will show you how the substitution works. I've placed a placeholder here called build_number, which my sed script is going to replace by the actual build number. I could put :latest here, but there's a problem with that. If I were to just use a hard-coded dockerrun.aws.json and always grab the latest image, that would work fine for most builds until I try to roll back, in which case I would roll back to an earlier dockerrun.aws.json file, which would happily go pull the latest Docker containers, which would cause no rollback to actually happen. It's again why it's important to use tagging and make sure your tags are consistent. This gets around that problem. So after we run the build.sh, what's going to happen is that this file is going to be generated into the build output directory with those build numbers replaced by the actual build number. And this is later, Danielle is going to show you this later on, is going to be used to generate the Amazon ECS task definitions, which are going to launch the actual containers on the cluster. Now back to our Jenkins. So that's what build.sh does, and it's a simple shell step. Finally, we have a post-build action, and this is where we tell CodePipeline where we just place the output artifacts. In this case, you recall from the script that we created a build directory and placed our dockerrun.aws.json into that directory. We're now telling CodePipeline that that's where the files live. That way, CodePipeline will pick the files up from that location, zip them up, and hand them to Elastic Beanstalk so the deployment works seamlessly. Now, going over to our test, it's almost exactly the same. We have a source code management step on our test. Again, it talks to CodePipeline, region US East 1, except that our category is now test instead of build. Our provider is Jenkins test instead of Jenkins build. And then when we go down to the post-build step, you'll notice that we don't have any output directories. And that's because our tests don't actually generate artifacts. It is simply a pass-fail step that tells you whether the test ran correctly or not. And now our pipeline is actually happily running the build stage. And I'm going to hand it back over.
So as Dan was saying, we will be deploying to Elastic Beanstalk. We have two environments where we're going to do the deployment, our beta environment where we're going to run the test, and then our production environment. Let's have a look at those two apps. They are completely identical, so I'll just go into the production environment. We run the multi-container Docker environment from Elastic Beanstalk. As we said, that would deploy onto Amazon ECS. We can see that the application, the version that is running is still the old one, old images and old title, and we'll see that at the end we'll have hopefully the new version running. We didn't modify any of the options here, so these are all the default options that we have. In our pipeline, what we need to specify for deployment to Elastic Beanstalk is simply to pick up the Dockerrun.json file from our build directory, and that's what we specify with the input artifacts. And then that's all it takes to deploy from pipeline into Beanstalk. And the same for our production environment. Again, we pick up the Dockerrun.json file from the build directory and put that onto Beanstalk. As we mentioned, Beanstalk can manage all the resources for you. One of them is our Elastic ECS cluster. We see that we have two clusters here that are prefixed by AWS EB for Elastic Beanstalk. Then we have our photogram beta for our beta environment, and then we have one for the production environment as well. We can go and take a look at the task definition that Beanstalk has created for us. So this task definition is created from the Docker run that we specified. We can see that it's using an image, and we substitute the build number text with an actual number that is the build number that we run, and that's all it takes for running ECS task basically on. The other thing we can check. We also mentioned that our test environment is going to spin up slaves on ECS. So the test is actually running now, so we should be able to see the test containers actually running. As we said, it's running on the staging cluster. We have one tasks running here. We can take a look at, again, the task definition for that, which is a Jenkins slave, which is what we expect to be. In this case, it's using the image that we specify at the beginning in our cloud configuration for the ECS plugin. And then it's passing some additional parameters to the command, to the Jenkins slave command. And these are needed to be able to talk back to the Jenkins master. Now, back to our pipeline, we can already see that our test is completed. It's all trained. It's now deploying onto production. We can take a look at the beta environment, and we should see that we already have the new version of the application running on beta. Here it is. And once the pipeline is completed, we will also have the same application running on production as well. We can switch back to the presentation now, and
kick you out.
Yeah. So just a few things before we end up. Few things that we'd like to take away from this session. Use the ECS CLI to run your application both locally and on an Amazon ECS cluster, especially if you're already using Docker Compose. That would be a very smooth transition for you. Make use of the ECS plugin to scale your build environment, run them again on ECS in containers. And finally, let CodePipeline do some of the work for you. So let CodePipeline orchestrate that process of moving your code from one stage to the other. So thanks very much. I hope you
Our pipeline is finished. Show the prod.